Okay, hello folks, welcome back. Another video following on from the last one, still talking about the binomial probability distribution. So in the previous two videos, I was talking about the binomial distribution, binomial probability model, and in the first video about this, I kind of showed how to manually code the binomials so we could obtain the probability mass function and the cumulative distribution function. And then in the last video, we imported the math library from Python and used that to do a similar sort of thing. Or we still had to create functions, but we were able to use some methods from the math library, such as the comb method to obtain factorials of numbers. So we could put those into the binomial coefficient, and we also made use of the floor method, which which calculated floor operator for numbers, which is something we needed when we were trying to work out the cumulative distribution function. So what I will do in this video is use the Scipy library, make everything much easier. So as I said, I've kind of demonstrated previously how to create functions to obtain the probability mass function and the cumulative distribution function for the binomial. Having these two things allows us to calculate probabilities for random variables that follow the binomial distribution and model processes where we're interested in the probability of getting a number of successes from a fixed number of trials, where each trial is independent, has the same success probability. Okay, so in this video, in this notebook, what I will again do is obtain the PMF and the CDF, the binomial distribution in Python, but this time I'll do it without having to create my own functions using the Scipy software library. So the Scipy library makes it easier for us to work with probability distributions. So to make use of the binomial distribution, we need to use a Scipy method or function called binom. So I'm going to start by, from the Scipy stats library, I'm going to import this binom module or method or function, whatever name you want to give it, I guess, really. So let's use an example, we'll use the same kind of motivating illustrative example from previous videos. Let's say an example where we want to work out the probability of getting 4 successes from 10 trials, where we've got a probability of success on each trial set to about 30%, 0.3, and calling using the binom .pmf, so calling this PMF method will and feeding it arguments for n, k or x, the number of successes, and p, probability of success, will return a probability of getting, say, 4 successes from 10 trials. So in this case, we're going to give it number of trials is n equals 10, number of successes is 4, so k equals 4, and the success probability per trial is 0.3, so probability about 30%. And in order to do that, remember we had to obtain the binomial PMF, we had to create our own function. We had to create a function that works out factorials, use that within the binomial coefficient, put the binomial coefficient into a formula for the probability mass function, and define a function to do that. But using Scipy, we can just use binom.pmf, specify we want 4 successes from 10 trials with a success probability of 0.3. So notice the order they're going in. And we get a probability of 0.2. So it's telling us about a 20% probability of seeing 4 successes from 10 trials when the probability of success on each trial is about 30%. Okay, so that agrees with kind of the figures, the types of the probabilities that have been returned for these values when we've used other methods that we've created ourselves. Okay, so nice and easy to use in Scipy, though, much easier than the previous way we've done things. So the CDF is also available as a method. So to use the PMF, we just use binom.pmf here. See, the CDF is also available as a method using binom.cdf, and that will, as you should know from previous videos, that will tell us the cumulative probability of getting at least 4 successes from 10 trials. So it'll tell us what's the probability of 4 successes or less from 10 trials with a probability of success of 0.3 on each trial. Okay, so let's do that here. We're going to, in order to obtain this, we're going to use binom.cdf. We're going to pass it in again. We'll use the same values, 4 successes from 10 trials, 0.3 probability of success. And you can see there we get a value of 0.4, 8497, etc. So we get a result that tells us the cumulative probability of getting 4 successes or fewer is about 85%. Okay, so that's the PMF and the CDF. Really easy using Scipy, much easier than the other methods that I've demonstrated. But a further useful method that we can use with Scipy using the binom function is something called a survival function. And the survival function is the complement of the CDF, so it's 1 minus the CDF essentially. So it tells us the probability that we won't get X or fewer successes from N trials with a probability of success of P on each trial. So for example, if we use the same values as previously, 4 successes in 10 trials with a success probability of 0.3. What the SF, what the survival function is going to tell us is the probability that we won't get 4 or fewer. Okay, so it's the complement of the CDF essentially. And so in order to use it, we just use binom.sf, 4 successes, 10 trials, 0.3% probability of success. And you see we get a value of about 0.15, so 15%. So the probability of not getting 4 or fewer successes is about 15%. Okay, when for a random variable that follows a binomial distribution. And note that that is the complement of the probability given by the CDF. So the CDF gave us, for these same values, gave us a probability of about 85%. And the difference between that and the total probability 1 is 15%. So if we took, if we add the survival probability and the CDF probability, they will sum to 1. Okay. So basically 1 minus 85% will give us 15% essentially. So survival function might be useful if you want, if you want to know how many probability of getting this value or fewer, then we can use CDF. But if you want to know the complement of that, what's the probability that we won't get 4 or fewer, then we can use the survival function method. So pretty useful. Okay, so what you're probably thinking is, why didn't I just demonstrate how to do all this in Scipy to start with, because it's much quicker and easier. But as I said previously, I thought it was kind of useful to develop some understanding of the binomial distribution by kind of looking at the PMF, the formula for the PMF and for the CDF, and looking at how those are calculated. All right, so in the next video, I'm going to make one more video on the binomial where I'll kind of just demonstrate how to simulate data that follows a binomial distribution. Should you want to create a random variable that follows a binomial distribution for use in to practice some sort of analysis. Okay, so that's it for now, but thanks for listening. I hope this was useful.